A strange new interstellar object has entered the solar system, and it's doing things no natural body should. It's called 3I Atlas, and over the past several weeks it's brightened by a factor of 5, shifted to a spectral blue that's more intense than our sun, and, perhaps most remarkably, it has manoeuvred in space. You heard that right. According to Harvard astrophysicist Dr. Avi Loeb, this object is not just drifting, it's actively changing its trajectory, without a tail, without gravity assists, and with no known natural explanation. And now, for the first time, scientists are tracking what appear to be mini-objects, possibly fragments or probes, ejecting from the main body. This isn't science fiction. It's November 2025, and the astronomy world is holding its breath. So, is this just a weird comet? Or have we just witnessed a technological maneuver by an interstellar visitor? Stay with us, because in this documentary we're going deep into the data, the visuals, and the voices that matter, from Loeb's explosive interviews to the latest satellite tracking from JPL and the Virtual Telescope project in Italy. Cut to animation of 3I Atlas moving across a star map, coloured blue. Overlay text, new December 19th closest approach. Overlay map, heliocentric position, orbital path, mini-object ejector. If you're fascinated by space mysteries, interstellar anomalies, and the possibility of something far more intelligent than us, hit that like button, subscribe, and turn on notifications. Because the countdown to December 19th has already begun, and what we learn next might just rewrite history. Let's start with what we know. 3I Atlas was first classified as an interstellar object. 3I meaning it's the third confirmed interstellar visitor, after Oumuamua and 2I Borisov. But from the very beginning, 3I Atlas has been different. It entered the inner solar system on a trajectory almost perfectly aligned with the ecliptic plane, the orbital highway our planets ride around the sun. Detected in late September 2025 by the Atlas survey system in Hawaii, it quickly raised eyebrows for its high speed, over 150 kilometers per second, more than 3 times faster than any rocket humanity has ever built. Then came October 29th. That's when 3I Atlas reached perihelion, its closest approach to the sun, at just over 203 million kilometers. Now here's where things got strange. Normally, when a comet approaches the sun, you expect sublimation, ice vaporizing into gas, forming a long bright tail that stretches away from the star. But with 3I Atlas, no tail, just a blindingly blue core. According to measurements from the Virtual Telescope project in Italy, the object's colour shifted sharply, its emission spectrum becoming bluer than the sun itself. That's not just unusual, that's nearly unprecedented in cometary science. Let's break that down. The sun emits a yellowish-white, light due to its surface temperature of about 5,800 K. 3I Atlas, while cooler, is emitting shorter wavelengths, which in astrophysics usually indicates higher energy transitions. This led scientists like Loeb to suggest this isn't natural outgassing. This is directed propulsion. A comet releasing gas would cool, darken, and show dust debris. But instead, it brightened X5, ejected 0 visible tail, and then, according to Avi Loeb, manoeuvred. On November 7th, Dr. Avi Loeb went on record in a live Newsmax interview, stating, "It manoeuvred. This is not what comets do." What was he referring to? Between November 6th and 9th, a constellation of observatories, NASA JPL, the Galileo Project Station in Las Vegas, and even private telescopes in Japan, noticed a deviation in trajectory. Simulations from the JPL Horizons database showed a non-gravitational acceleration equivalent to 5 billion tons of mass being ejected. But again, no visible jets or fragments. Imagine a car accelerating forward, with no tyres, no gas, and no exhaust. That's what 3I Atlas just did. Loeb compared the data to Oumuamua, which also displayed acceleration without visible propulsion. But even then, 3I Atlas is behaving more energetically. In Loeb's words, this is more active than anything we saw in 2017. And now we come to the latest revelation. As of November 22nd, several observatories, notably the Virtual Telescope in Italy and the LCOGT network in Chile, have detected brief flashes and small clustered objects trailing 3I Atlas. Radar imaging's limited, but preliminary triangulation indicates that at least 3 mini-objects have been released, each less than 100 meters in size. NASA has not yet publicly commented. But behind the scenes, according to a source close to the Galileo project, Loeb is actively requesting image access from the Mars Reconnaissance Orbiter, which reportedly captured high-resolution photos of 3I Atlas as it neared the Martian orbit. That's right, Mars may have gotten a closer look at this object than Earth ever will, and the images still classified. Enter Representative Anna Paulina Luna, who on November 18th formally demanded a briefing on the object's nature and image transparency. We now have Congress asking the same question we are. What exactly is this thing? So what's the big deal about colour? Well, in astronomy, colour tells you temperature, composition, and energy levels. Most comets shift toward red or yellow as they burn through carbon compounds and dust. But 3I Atlas is doing the opposite. Spectral analysis shows a composition rich in nickel, with low iron content and no significant volatile ices. Again, very unusual. This combination, metal-rich, no tail, bluer than the sun, has led Loeb and others to consider that this may not be a comet at all. Possibilities now being modelled include a metallic asteroid with internal outgassing, a technological probe, possibly self-correcting its trajectory, a multi-body cluster ejecting mini-objects for measurement. What makes this even more curious is the location. 3I Atlas is moving in a coplanar orbit, just like the planets. If you wanted to approach Earth without drawing attention, this is the stealthiest path. There's one more piece to this growing puzzle. 3I Atlas's incoming trajectory traces back to a region of the sky just 9 degrees off from the famous 1977 WOW signal, the unexplained high-intensity radio burst detected by Ohio State University's Big Ear telescope. Dr. Loeb has gone on record speculating that if there were a repeating technological origin, this region might be worth watching. And now, a fast-moving, colour-shifting, jetless object just emerged from almost that exact part of the cosmos and is possibly deploying mini-components. Coincidence? Maybe. But at this point, even the most conservative observers are starting to ask, what are we really looking at? All of this leads to one date, December 19th, 2025. That's when 3I Atlas will make its closest approach to Earth. During that window, coordinated observation campaigns will attempt to capture high-resolution optical and radar data, revealing whether it fragments further, new jets appear, mini-objects activate, or the entire body decelerates unnatural. Avi Loeb and the Galileo project have prepared proposals for follow-up study, and NASA's Deep Space Network is adjusting tracking patterns. At this very moment, scientists around the world are preparing for what might be a once-in-a-century event. Because if the current trajectory and behaviour persist, we may be looking at the first confirmed interstellar technological visitor. Or, at the very least, a natural object that defies every known model in planetary science. So what do we really know? It's fast, it's blue, it manoeuvred, and now it might be releasing mini-objects. The story is still unfolding, and we're just getting started. In part 2, we'll dig deeper into the image analysis, explore the mathematical models, and examine the possible technologies that could produce this kind of behaviour. We'll also look at what happens if 3I Atlas slows down or changes path again, what that would mean for physics, for science, and for us. If you want to follow this investigation as it develops, subscribe now, turn on notifications, and leave a comment. Do you believe 3I Atlas is natural or something else? I'm reading every single response. December 19th is coming. And so is the truth. Previously, we explored the rise of 3I Atlas, an interstellar object entering the solar system in late 2025 that has since defied every known natural model. It moved without gravity. It glowed blue, bluer than the sun. It ejected jets but no tail. And now? It may be releasing mini-objects, possibly on purpose. With December 19th approaching fast, scientists are entering crisis calculation mode. Because if 3I Atlas is not behaving like a comet, what is it doing? In this second part of our investigation, we'll examine the mathematical model of its non-gravitational acceleration, why the 7 visible jets have scientists scratching their heads, the evidence of structured ejection, not fragmentation, and most importantly, what could produce that unnatural blue light. Let's dive deeper into the data. First, let's return to a key visual. On multiple days between November 9th and November 20th, the Virtual Telescope project in Italy, using stacked image sequences from their 0.4 mem robotic telescope, captured distinct linear rays of light emerging from 3I Atlas's fuzzy core. At least 7 visible jets, radiating in asymmetric angles, almost like thrusters on a rotating axis. But still no coma, no debris field, no tail. That's where the mystery gets weirder. Traditionally, comets develop long tails because solar radiation and the solar wind push evaporated material backward. It's automatic, a product of sublimation. So why doesn't 3I Atlas have one? Spectral data indicates no major water ice, no carbon dioxide sublimation. Instead, we're seeing traces of nickel, chromium, and sulfur compounds, not typical cometary materials. As Dr. Gianluca Massi of the Virtual Telescope project stated, the object is active, but it doesn't behave like any comet we've seen before. Let's talk math. According to NASA's Jet Propulsion Laboratory models, 3I Atlas is not moving as expected for a body under pure gravitational forces. The standard model predicts perihelion velocity, 115 km expected arc shift post-perihelion, 0.002 degrees per day, observed arc shift up to 0.008 degrees per day. That means it's accelerating away from the Sun faster than expected. Now calculate what that would require. To accelerate at that rate via outgassing, 3I Atlas would need to expel at least 5 billion tons of mass. Yet no mass loss trail is visible. And even more confusing, the object's rotation hasn't changed significantly, suggesting thrust was carefully managed. That's not natural. That's deliberate course correction. Over the past week, amateur astronomers affiliated with the Las Cumbres Observatory Global Telescope Network, LCOGT, in Chile and South Africa, have observed rapid blinking points along the predicted orbital path. These flashes appear offset from the primary body, and some seem to track parallel movement, not radial ejection. If fragments were flying off from natural breakup, you'd expect a scatter cone, like a shotgun blast. But what's being observed is parallel movement, suggesting these objects are guiding along a similar vector, possibly with their own propulsion or passive guidance. Some even show a stable light curve, indicative of spinning bodies reflecting sunlight, possibly metallic. The size, estimates place these mini-objects at 20 to 80 metres in width, about the size of a bus. But here's the real shocker. Their emitting separation from 3I Atlas is not random. It follows a geometric ratio, suggesting either deliberate release intervals or a synchronized cluster. Dr. Avi Loeb, speaking in a November 22nd online forum, proposed, "This may be a swarm, either remnants of a structured object or small reconnaissance instruments released during perihelion. In other words, probes. According to 2 sources inside the Galileo project, there is growing pressure on NASA's Mars Reconnaissance Orbiter, MRO, high-rise team. That's because the MRO had a unique vantage point on 3I Atlas between October 25th and November 3 as the object crossed Mars' orbital radius. At least 12 image sets were reportedly taken with the high-rise camera, which boasts a resolution of 25 centimeters per pixel, far superior to anything Earth-based. Yet as of November 24th, none of these images have been released. Why? Officially, NASA cites data prioritization and image calibration. Unofficially, congressional pressure is mounting. Representative Anna Paulina Luna, in a formal letter to the House Oversight Committee, wrote, "The American people deserve to know if we are observing a natural object or something more. Image suppression, in this case, undermines scientific transparency." It's worth noting that NASA has historically taken months to release high-resolution imaging of Mars flybys, but in a publicly controversial case like this, silence only deepens the mystery. Back to that strange blue glow. In astronomy, blue shift typically means an object is moving toward us, compressing light wavelengths due to the Doppler effect. But 3I Atlas is moving away, not toward. So this blue shift is not from motion, it's from emission. According to recent photometry from the Subaru telescope in Hawaii, the peak emissions of 3I Atlas fall near 450 nanometers, well into the blue visible range. That's odd because thermal objects that emit at this wavelength must have a temperature above 6000 K. hotter than the sun's surface. But other instruments, such as the Las Vegas Galileo Project Observatory, recorded infrared emissions consistent with a body cooler than 1200 K. That's a contradiction. A body that cools should not emit blue light. Period. Unless the blue glow is not thermal, but powered, perhaps by a luminescent reaction or engineered material. Or we're seeing residual ionization, like a gas jet energized by an internal reactor or reaction chamber. Again, speculation. But the contradiction remains. The object is too blue and too cold. No one can explain that. Behind the scenes, the Galileo project, led by Loeb, has activated tracking nodes in Las Vegas, Arizona, and an upcoming Chilean site to gather as much data as possible during December 19th. Unofficially, Loeb is calling this a once-in-a-century opportunity to observe a possible interstellar artifact in action. The project is also working with neutrino detection researchers, wondering whether the object may release non-electromagnetic particles as it approaches. Meanwhile, a theoretical intercept mission, dubbed Juno Revector Window, has been proposed for March 2026, using the Juno spacecraft if a redirect maneuver is feasible. That possibility hinges entirely on what happens next month. So let's sum up what we've uncovered in this episode. A comet with no tail 7 jets, but no visible mass loss. A blue glow, but not from heat. Mini objects released but not scattered. Mars orbiter images, still unreleased. Whatever 3i Atlas is, it's not ordinary, and it's doing something no rock, no ice ball, no fragment should be doing. In part 3, we'll go further. We'll break down the theories on propulsion, show how objects like this could be engineered, and compare it directly to Oumuamua, Borisov, and past anomalies. We'll also reveal the classified modelling from Harvard's internal white paper, which may be the smoking gun connecting 3i Atlas to known alien artifact signatures. So make sure you're subscribed, notifications on. Leave a comment below. If it's not a comet, then what is it? I want to know what you think before December 19th reveals it all. In our previous episodes, we uncovered the objects: sudden manoeuvring, anomalous blue emissions, absence of a tail despite jets, and the mysterious release of smaller objects. Now we shift into even more controversial territory, because today we're exploring the engineering implications. If this object is behaving as if propelled, what force is driving it? Could it be natural outgassing, as some scientists claim? Or is there deliberate design behind its movements? Today we go line by line through the math, the mechanics, and the Galileo project's internal modelling, spearheaded by Harvard astrophysicist Dr. Avi Loeb. This isn't just speculation, it's engineering analysis. Let's begin with a simple truth. In space, motion requires force. Under Newton's laws, for an object like 3i Atlas to change direction or accelerate, it needs to eject mass in the opposite direction. That's how rockets work. But 3i Atlas has no visible exhaust, shows no thermal trail, and exhibits vector changes that are smooth, not chaotic, as if corrected or aimed. So let's apply real numbers. According to Loeb's equations, to account for the observed shift in trajectory on November 9th, the object would have had to produce a thrust of 1.7x 103 newtons, roughly equivalent to the sustained thrust of an RL-10B2 upper stage engine, the kind used on satellites. But 3i Atlas is 5 km wide, no signs of active combustion, and doesn't rotate erratically, as would be expected from natural gas vents. Loeb's conclusion: the only plausible natural explanation would require massive outgassing through invisible compounds, something we've never observed. And even then, it would be an engineering-grade vent system, not a random sublimation event. Now let's talk about the jet layout. On November 17th, stacked image frames from the Virtual Telescope project showed 7 visible jets, positioned in what appeared to be a symmetrical pattern. This isn't just artistic symmetry. This is geometry, functionally useful geometry. 3 jets on the rear left, 3 on the rear right, 1 possibly at the centre line. Such positioning would allow pitch control yaw stabilisation, minor course correction in 3D space. Sounds familiar? That's exactly how reaction control systems work on human-built spacecraft like the ISS or SpaceX Starship. So now we ask, did nature somehow accidentally build a thrust geometry that mimics space maneuvering systems? Or are we looking at a structure designed with those very principles? Here's where the story turns. According to sources within the Galileo project, a non-public white paper was submitted to Harvard's Department of Astronomy on November 21st, titled Non-Gravitational Acceleration and Controlled Ejection Analysis of 3I Atlas. In this paper, Loeb and co-author Dr. Felix Rahman, a computational physicist at MIT, simulate propulsion from internal vents using metallic hydrogen storage, a theoretical tech first suggested for deep space propulsion in the 1990s. Key findings: jet ejection timing matched light curve anomalies, course deviation matched simulated vent angles. Mini-object ejection was most consistent with preloaded deployments rather than explosive fragmentation. The conclusion: the data does not confirm artificial origin, but it increasingly resists classification under known natural phenomena, which, in scientific terms, is as close to saying we may be looking at technology as you'll get in a peer-reviewed draft. This white paper is currently undergoing internal review, but leaked abstracts have been shared with independent analysts, including those at the CT Institute. Let's talk about the material makeup of 3I Atlas. Most comets contain water ice ammonia, dust carbon-rich compounds. But spectral scans taken on November 10th by ESO's Very Large Telescope in Chile revealed high reflectivity at 340 nm and absorption bands consistent with metallic nickel, not dust, not ice. This suggests a surface coated or embedded with nickel-rich compounds like invar or monyl alloys. Now here's where it gets technical. Nickel alloy surfaces resist radiation damage, conduct heat, and are often used in nuclear shielding. So why would a so-called comet be covered in this? Unless it's a shell, possibly engineered to protect an inner mechanism from solar radiation. This brings us back to the question of the object's emission. The cold body emitting blue light, nickel alloys, can fluoresce under UV bombardment. That could explain the blue, if the surface is artificial. As we covered earlier, 3I Atlas's incoming trajectory aligns within 9 degrees of the 1977 WOW signal source. Critics argue 9 degrees is too large, but Loeb counters. In galactic navigation, a 9-degree window over light years of travel is precision, especially if you were aiming for the ecliptic plane, which 3I Atlas entered with astonishing accuracy. And here's something few noticed. Between November 14-18, the Green Bank Telescope in West Virginia performed radio scans of the object's approach. They detected narrow band anomalies at 1.42 GHz, the hydrogen line, the same frequency associated with intentional signals in SETI searches. No data has been published, but we've confirmed internal logs labelled passive narrowband excitation, source unknown. Was it a signal? Unknown. But if it was noise, why isn't it public? Let's play engineer. If you were designing a deep space interstellar probe and you wanted it to survive stellar radiation, adjust course without being noticed, release subprobes, and maybe scan Earth from a safe distance, how would you build it? Metallic shell, no large moving parts, internal propulsion, infrared silent ejectable data pods, or sensors. Sound familiar? Because that's what we're seeing. Loeb's working hypothesis, also outlined in his 2021 book Extraterrestrial, is that advanced civilizations might use fully autonomous light sail-driven craft that shed pieces when needed. 3I Atlas seems to fit that logic. The only thing missing? A sail. Or maybe that's what was jettisoned at perihelion, a propulsion stage discarded once the object began its scientific phase. We now stand at the edge of one of two possibilities. Option 1, 3I Atlas is a natural interstellar object performing the most unlucky, unexplainable combination of phenomena ever witnessed. Option 2, 3I Atlas is not natural, but something made. In Part 4, we'll explore what happens next. The final approach. The December 19th observation windows. What failure or silence might actually mean, and we'll examine theories spreading quietly in research forums, from alien probes to cosmic tests, to Earth being observed in return. Make sure to subscribe so you don't miss the final part. And let me ask you directly, If this isn't nature, are we ready for what it might be? Comment your thoughts, and I'll see you in part 4. The object called 3I Atlas, the third confirmed interstellar visitor, is now on final approach. For months, it's defied physics, puzzled top scientists, and possibly, just possibly, released artificial mini-objects into space. And now, on December 19th, 2025, just 6 days before Christmas, it will pass closer to Earth than any known interstellar body in recorded history. Telescopes are locked, radio receivers tuned, Loeb's Galileo project is online, and thousands of amateur astronomers, scientists, and even government officials are watching one point in the sky. What happens in the next 72 hours could rewrite our understanding of physics, interstellar travel, and possibly our place in the universe. Let's walk through the final stage, step by step. As of December 17th, NASA JPL's Horizons database confirms that 3I Atlas will pass within 0.23 AU of Earth, approximately 34 million kilometers, or roughly 90 times the distance to the Moon. But it's not just the distance that matters, it's the approach angle. 3I Atlas is entering along a trajectory nearly coplanar with Earth's orbit, with a relative inclination of only 1.3 degree, meaning it's skimming along our solar plane like a vehicle merging onto a freeway, not diving in like a rock from deep space. That's the kind of approach a probe might use, not a random fragment. It also makes imaging easier. On the night of December 18th, Earth's night sky will give us a full, unobstructed view of the object's approach. No sun interference, no horizon loss. The world will be watching. Let's talk telescopes. James Webb Space Telescope, JWST, will not observe 3I Atlas due to pointing restrictions near Earth. However, Hubble Space Telescope has a December 18th window. Goldstone Radar Facility will bounce signals starting December 19th at 03:00 UTC. Greenbank and Arecibo successors will monitor for radio anomalies. European Southern Observatory is deploying high-speed photometry for any light curve fluctuations. Even NASA's infrared survey satellites, NEOWISE and SPHEREX, have adjusted tracking parameters to scan for low-temperature emissions, hoping to catch hidden propulsion or thermal vents. But the most anticipated data comes from Earth. Thousands of synchronized amateur telescope arrays via the Global Meteor Network will contribute to a real-time composite image stack. This means, on December 19th, we may get the first ever crowdsourced live video of an interstellar visitor. So, what do we expect to see? According to Avi Loeb and the Galileo project, there are 3 plausible outcomes. 3I Atlas splits apart like many comets do. We see debris, chaotic spin, perhaps a dusty coma finally emerging. Verdict: a bizarre but ultimately natural object, possibly ice-free and metal-rich, but still from a random star system. The object emits a sudden vector change. It slows, curves, or aligns to avoid Earth's observation window. Similar to how Oumuamua drifted, this would be near impossible to explain naturally. Verdict: artificial propulsion, likely not of human origin. As it reaches its closest point, it deploys another cluster of mini-objects, or emits a structured radio signal. Even a simple binary burst would be enough to trigger global headlines. Verdict: confirmation of deliberate design. Loeb has already stated, if 3I Atlas reveals intention, by motion or signal, it's not a comet, it's contact. Why haven't we heard from NASA directly? That's become part of the mystery. Despite mounting evidence, leaked observatory reports and internal congressional letters, NASA has not formally commented on the jet activity or mini-object hypothesis. But in closed-door briefings, according to Representative Anna Paulina Luna, 2 members of the House Intelligence Committee were shown classified infrared data from the Mars Reconnaissance Orbiter. While the content of that data is unknown, the very existence of those briefings suggests government agencies are taking 3I Atlas extremely seriously. There are now whispers of a limited release of findings after the December 19th pass, but only if public observation forces disclosure. This feels increasingly like a countdown not just to discovery, but to a moment of institutional reckoning. As the object nears, Loeb issued his final public analysis via the Galileo project site. Regardless of its origin, 3I Atlas is performing actions that challenge known physical models. If it fragments, we will know. If it maneuvers again, we must ask harder questions. His team has prepared a machine learning classifier to monitor light curve anomalies in real time, meaning that if any sudden propulsion or jet asymmetry appears, they'll flag it within minutes. They're also preparing a remote server release of all data to ensure the public sees what's happening, even if institutions hesitate. And here's the most chilling part. This may be the first probe we didn't detect, but that detected us. But let's be honest. What if nothing happens? What if it passes quietly? No signal, no maneuver, no debris. That's still not the end. Because even in silence, 3I Atlas is now the most anomalous interstellar object ever recorded. The data collected, spectral, kinetic, rotational, emission, trajectory, will take years to fully understand. And it may turn out this wasn't the signal, but the test. What if this was reconnaissance? What if Earth is not being ignored but evaluated? Are we ready to accept that possibility? We live in a time where most science communication plays it safe, but this object, it's forcing the scientific community, the public, and even governments to stare into the void and say, we don't know what this is. And that's historic, because not knowing is the first step to finally discovering. Whether 3I Atlas is a bizarre natural relic, a piece of alien tech, or something we haven't even imagined yet, it's already changed everything. So here's what you can do. Watch the sky on December 19th. Track telescope data via the Galileo Project, Virtual Telescope, and NASA JPL updates. Stay skeptical, but stay open. And most of all, if you want to follow this story as it continues to unfold, subscribe now and turn on notifications. I'll be making updates in the hours after the approach, especially if we see signal bursts, mini probe releases, or controlled flight. Drop a comment below. Do you think 3I Atlas is a test, a visitor, or just a rock from somewhere strange? I read everyone. I want to know what you think. This is it.